Okay, 7.4 day 2 for logarithms. So logarithms on your calculator. We're going to get to doing some of these on your calculator. First, you got to know common log is anything that is like log. It has a log with base 10. It's base 10. And we kind of write that like this, log 10x. The little 10 is down there. If there is no 10 written there, it's just log x, like there's no base at all, it's assumed that it's base 10. Natural log is log with base e. We learned about e a little bit earlier in the chapter. E, so if you have natural log, that's like log base e x, which is the same as ln x. ln means natural log or log base e. And there's a button like that on your calculator. So using your calculator, because your calculator is in base 10. Your calculator is always in base 10. We're going to learn other bases later, but we'll do base 10 this time. You're going to plug in log 8. So you just press where log 8 gives you a decimal. Natural log, if you see natural log on here, oh, there it is. Right by the log, ln. That next one is 0.3. So hopefully you want to just plug in these numbers and make sure you're getting it right. Your calculator, you're finding the buttons, basically. Inverse functions. So logarithms and exponential functions are inverses. So like a to the power of b equals c is an inverse with log base a c equals b. They're inverses. And I showed you yesterday, the big L, you can switch, or the swirly, you can switch. So let's do some rewriting. And this, just so you know, is read like this. Log base 2 of 8. That's kind of how you read that thing here. So going back to some rewriting, I'm going to use my swirly and my big L. So swirly, b to the power of p equals n. B to the power of p equals n. Do that same thing. 2 to the power of 5 equals 32. It's just telling you what order to go in. 7 to the power of 3 equals 343. Okay, now the other way, so this was in log form, now it's an exponential. Now I got exponential and we're going to change it to log. For log, I do the big L. So log base b of n equals p. Just tells you what order to go in. Log base b, n equals p. So this one, log 5, 625 equals 4. And the last one, log base 8, 512 equals 3. Just like that. Last thing for today is finding the inverse function. So you can do this. I put some steps here for you. Number 1, you're going to switch the x and y. So it's x equals 6 to the power of y. Then you want to isolate the function. You want this function to be by itself. Well, this one, the exponential part, already is by itself, so you're good. I'm going to add a little caveat in here. Y on left. I'm sorry, whoa, right. You gotta switch it so that I can do my magic things I showed you. So 6 to the y equals x. Because now I can do the big L, change it to log, which is the next step, convert. So log base 6, x equals y. And then continue to solve for y if needed. That one, the y is already by itself. So there's my inverse. Next one, step 1 is switch the x and y. So x equals ln y plus 3. Get the log part by itself. Well, that's that part. It's already by itself, but I need to move the x to the other side. So ln y plus 3 equals x. Here's tricky one with this one. ln is log base e. So since I'm going to change it, I need to put it into log base. Just change this to log base e. They mean the same thing. Log base e, ln mean the same thing. But now I can do the swirly. E to the power of x equals y plus 3. And then now we're going to do the fourth step. Get the y by itself. Subtract 3 over. So e to the power of x minus 3 equals y. I think 2 more of these. Switch the x and y. Okay. We got to get this part by itself, just this. So the first thing I'm going to do is add 7. So x plus 7 equals 5, 3 to the power of y. Still got to get this part by itself. Right now it's being multiplied by 5, so I'm going to divide by 5. So x plus 7 over 5 equals 3 to the y. Now that part's by itself. Now to do my little big L switch thing, I need this to be on the other side. So I'm just going to switch it over. Equals x plus 7 over 5. Because now I can do log base 3 of x plus 7 over 5 equals y. And there you go. I ran out of room or ran into that hole. The y is by itself, so it's good. One more. Get a function like this, switch my x and y. Log base 4y plus 8. So I'm going to move that 8 over to the other side. X minus 8 equals 1/3 log base 4y. I want to get this log by itself. Right now it's being multiplied by 1/3, so to get rid of that, I'm going to multiply by 3. Because this and this will cancel out. This side I'm just going to distribute. So I got 3x minus 24 equals log base 4y. To do my little fancy swirly, I need this to be on the other side. So log base 4y equals 3x minus 24. So I can do that thing. 4 to the power of 3x minus 24 equals y. And there's my inverse.